Okay, so guys, so let's say for here, right, in this seminar, we try to focus on the main topics we're gonna come out in your first exam lah. So this seminar exercise, right, we include chapter 2 and chapter 3. Okay, mainly these two chapters. Chapter 4 don't have lah. But 2 and 3 is the main concern in your first exam every time like that. Okay, every year your first exam main concern is chapter 2 and chapter 3. So I will do every topic, okay, probably like one or two questions, okay, then to brush up your basic a little bit because this week is holiday okay, so I believe you all maybe you all feel like, yeah, teacher, a lot of things I forget already, okay, because holiday mode okay. So what happened here is, okay, so I try my best to actually go through whatever I have in this book, okay, but I'll go through every topic okay, I try my best every topic I do one question, I do multiple stuff, okay. Oh guys, a lot of students sending me their SPM result. Today is SPM result day. Okay, a lot of students sending me their results already. Okay. I reply them later Okay, so now so guys, the answer is actually here Okay, the QR code with extra materials. Okay, and then what happened here is, you see okay guys, in the front we actually included a lot of short notes, correct? So all these short notes you realize that it's in colored, I think so. Okay, supposedly it's in color And how it goes is, you see, you can see in this way we give you short notes and then we give you like the discussion, okay, which is the question and the answers. It works like this. Okay, it works like this. You see, we got short notes, okay, and then later on got discussion, and all this discussion observation, right, they all appears in those type of question that includes your experiments. Okay, so I try to go through the category we have so I think chapter 2, okay, chapter 2 we have what we actually have for experiment will be your heating and cooling curve, okay, which is your melting point and your freezing point of your naphthalene. Okay, so that's why you see we give you procedure just in case because I think first exam they won't ask you procedure, okay, but just in case. But of course, if you see going down, you see I got discussion, okay, and then what else got procedure, observation, and all this. Then you can see in chapter 3 chapter 3 you will see this the empirical formula. Empirical formula got two one is magnesium oxide, the open and close the lid one, okay, and then we also have the second one of your chapter 3 is actually your copper oxide. Okay, remember this the burning of ethanol to heat up the copper oxide together with the hydrogen gas. Okay, so of course all the procedure provided, all the discussion provided. Discussion probably is your exam question so you have to try to go along with this. Okay, so of course, and then we have actually other type of questions Okay, most importantly, we have also this thing called the stoichiometric calculation, where we play along with this formula, kind of the mass over molar mass, volume over molar volume. Okay, so which book is this? Hey, this book is seminar have you received seminar book? Did you know hey, did you actually fill up the hard copy? I mean, there's a Google form for you to fill in. No, if you don't have, then you just go to the website. Okay, you know there's a website. The website actually have PDF notes. So if you know, usually we don't give PDF notes one. Okay, this is the one and only event in TTC that we actually provide PDF notes. Okay, so you know the website. There's a website just in case you didn't know. No, then how you know today got seminar? Huh? How you know today got seminar? Seems like you also don't know Hey. Okay, never mind. I send it to you I send it to you. Okay, I send a link to your WhatsApp. Okay, so what you do is you try to scroll through the website, and then you see there are a few buttons for you to click in. Okay, so you can get hard copy notes, you can get PDF, and then you can get recorded video. Okay, everything in the website. Okay, everything is actually go through the website one. Okay, so this one, what happened here? This okay, so what happened here is okay. If you don't have the book, never mind. Okay, so you can just go through with a PDF. You can open up your PDF and then you can add whatever comments you want to add in, or you want to take a paper or write on it also can. And then this video, we will actually post it on TTC YouTube channel also. So any guys, all subject okay, all subject seminar video will post on TTC YouTube channel. So later on, you all can just again same thing, go to the website and then you scroll then you click for the one to get you the recorded video. Everything is there. Okay, so everything for here is actually free and then also provided with your recorded video. Okay, so guys, as I mentioned, guys, my plan for today, I wouldn't want to go through any like teaching anymore. Focus mainly on what? On doing exercise. Okay, so the more exercise we can do today, the more you all can actually like go through in the exam. So what I can do is, guys, you straight away go for exercise at the back. Okay, around page number 12. This one, page number 12. I do some basic one first lah. So I go through one by one with you guys. The page number 12 this one page 12 Okay, so guys, I try to do as much exercise as possible because exercise more important Okay, so now we have this type of question, guys. Definitely, guys, in your first exam confirm, okay, confirm plus job confirm got this type of question You can see that what is meant by proton number and nuclear number, and then they give you like multiple unknown elements. Okay, they will ask you like maybe to determine the proton, determine the nucleon, determine the electron, determine electron arrangement. Okay, many questions like this. Okay, so what we see from here is we have RSTU, and then they are given all the numbers here: nucleon, proton, neutron, proton. So just in case you all didn't know, on top is nucleon, and then bottom is proton. Just in case you all didn't know. Okay, so what is meant by proton and nucleon? So guys, with this this one, these two definition, right? Very common in your first exam. So you must memorize. So what is meant by proton? So as we know, proton means what? Proton means that it's actually the number of proton in the nucleus. Because where proton located, it's actually like in the structure. Remember when we draw like electron arrangement like this, okay? But where's proton? It's inside the nucleus. So that's why when you try to define proton number, you must say the number of proton in the nucleus of an atom. So if you never go and say in the nucleus of an atom, if you miss out this part, no marks. If you just say, now, what is proton number? It's number of proton. Doesn't make sense, right? You have to say number of proton in the nucleus of an atom. Okay. Then same thing goes for nucleon. Guys, what is nucleon? Nucleon is technically proton, as we know, proton plus neutron. So again, nucleon is actually the total number of your nucleus. You know why? Because where is proton? In the nucleus. Where's neutron? Also in the nucleus. Okay. So definitely we can actually say that proton plus neutron, we say that it's a total number of proton and neutron in the nucleus of an atom. So definitely you must go in this way So you can see proton number is the number of proton in the nucleus of an atom. Then you say nucleon number is the total number of proton and neutron in the nucleus of an atom. Okay, so you see this is the one that I highlight is the keyword. Okay, and then we state the number of electrons in atom T. So how do I know electron? Same as proton. So if got 19 proton, then got 19 electron. Okay, so 19. So what is the number of neutron for T? How to get neutron? So we know neutron is like the nucleon equals to proton plus neutron. So to get neutron, you throw your proton to the other side. You take nucleon minus your proton. So we take 39 minus your 19. 39 minus 19, you'll say it's 20. So you see 20. Okay, and then after that, what's next is, okay, we have your meaning of isotope. Guys, this one also very common in exam. What is the meaning of isotope? Same something, but different something. So guys, this one got two ways to memorize as we actually say always choose one. Choose the one that you prefer and then go along with it. Okay, don't memorize both. Because if you memorize both, you might actually confuse yourself in future. Okay, so what's the meaning of isotope? Same number of proton, then different number of neutron. Okay, so you can see same number of proton but different number of neutron. You see, I highlight the one I mentioned. Number of proton, you match with number of neutron. Okay, but if you say, teacher, can I use same proton number? Can, but you have to match with different nucleon number. So different package, different keyword. So I will say, guys, choose your one that you prefer to memorize So don't actually like memorize both. Then in exam you go and you accidentally go and mix and match. You say same proton, different number of neutron. Then no good. Okay, so this is wrong. Okay, If moving on, which pair of isotopes, which pair of atom are isotopes? Same proton, okay? So who got same proton? You see RSTU, same proton, 6 and 6. This is the only two, no? So explain answer, because they have same proton but different neutron or different nucleon. Okay, up to you lah. So we say S and U because they have same proton number but different nucleon number. Okay, basically you just repeat your definition one more time. That is your explanation for how we know it's isotope. Wow, my student SPM chemistry A plus, eh? Yay, so happy. Oh, she got 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, yeah, 9A. Got one more B plus is Chinese. Okay, and then state two different physical properties between two isotope. So guys, when we talk about isotope, right, we got same something, different something, but now they want to actually link to this thing called physical property. So if you have different physical property, so what are physical property? So if you think about it, physical property is something that you can measure, such as what? Melting point, boiling point, such as density, such as like electrical conductivity, okay, solubility in water. All this is something that you can actually measure. But then if you want to try to link to chemical property is about reactivity with your water, with oxygen, with this and that lah. So you have to make sure you know how to differentiate physical property and chemical property. So again, from here we say state two different physical property. So we say that boiling point, melting point, atomic mass, density. All this is all the choices of our answers lah for physical property. Okay, and then will the two isotopes react the same way when heated with oxygen gas? So guys, you see, they got different physical property, but they supposed to have same chemical property. Okay, because see, when they say okay, heated with oxygen, because what they say is now heated with oxygen. Heated means experiment wise, correct enough. So when we are actually doing experiment, they supposed to behave the same. Why? Because reactivity depends on what? Reactivity depends on the last number of your valence shell, basically your valence electron. If the two things you have right now is the same valence electron, then they're supposed to have the same reactivity, they're supposed to have the same chemical properties. So you can see from here, we will say that yes, okay, they will actually have the same reaction, okay, because same number of valence electron and same chemical properties. Okay, and moving on, time to memorize some samples of your isotopes. So here in medical field, what isotopes we have? The common one for medical field is basically the cobalt-60. Cobalt-60 for what? Because cobalt-60 give out gamma ray, and gamma ray is very strong. It's a very strong radiation that can kill your bacteria, kill your virus, and even your cancer cell. So you can see that from here. So to kill cancer cell. Okay, for agriculture, agriculture means for plantation. So for plantation, it's something related to fertilizer. So we have this thing called the phosphorus 32 for you to study whether your fertilizer is good or not. So we can say to study the absorption of fertilizer by plants. And then moving on for archaeological, for your fossils, okay, for the dinosaur bone and stuff, okay, so we use carbon 14 for you to estimate. Guys, the word must be estimate. Cannot use calculate, cannot use any other word. Okay, must use the word estimate. Oh, not bad, not bad. A lot of students sending me their results. I'm so happy. Okay, well, for industrial areas, guys, industrial actually got many samples lah. So for what I put here is we put solid 24 is for you to detect like any leakage in your piping. So you can say to detect leaks in pipes. Okay, and and the next question is, you see, we have PQR, melting point and boiling point. Okay, guys. So how do you do this kind of question? Always try to remember, before melting point means it's actually not melted, so it's solid. After melted is liquid. After boil is actually gas. So you go in a flow like this lah. If the question later on is below melting point, then you can say it's solid. Above then liquid, above boiling then gas. Okay. So suggest the physical state at room temperature. So what is room temperature? Usually it's around 27 degrees Celsius. So if it's 27 degrees Celsius, I'll try to check. Is 27 higher than negative 183? Yes. Higher than negative 89? Also yes. So it's actually melt and boil. So basically it's gas lah. But for Q, you see, Q 27 is higher than 15, which is melted, but not over boiling. So it's not boiled. So it's supposed to be stay as liquid lah. Then for R, 27 is not even over melting point. So therefore, I will say R is a solid. So you can see PQR is gas, liquid, and solid. Okay, Okay, while boron exists naturally as two isotopes, which is 19.9%, which is this B10, okay, and 80.1% is a B11. Okay, boron 10 and boron 11. Calculate relative atomic mass. Guys, how do we calculate relative atomic mass? Basically, is to take your percentage, multiply your atomic mass, percentage, multiply atomic mass, and then total up together, divide 100% because percentage maximum is 100 lah. So what you do, take 19.9 times 10 plus 80.1 times 11 divide 100. So you can get something like this. Okay, so you see, you get like 10.8. So I'm just gonna go through with you lah. So just a simple concept of calculating your atomic mass in your isotopes. Okay, it's like finding average lah. So it's a very simple concept. Okay, but then if you go to the last one, okay, this last one is something that is quite complicated lah. Why complicated? Because see, they say sulfur got two isotopes, 34 and 32 lah. And then they say the relative atomic mass of sulfur is 32.1. Means that the average, the final answer, the average between 32 and 34 is 32.1. What is the abundance of both isotope of sulfur? So guys, how do you do this kind of question? Is where you're gonna try to actually like do a reverse calculation of what you did in the previous question. So what we know is the average, okay, for 32 and 34 is 32.1. But then because the average right now is in different percentage, it's not like 32 and 34 total up divide 2. It's not just that easy. So you have to actually go along with the percentage. But the point is, I need to have the percentage of sulfur So I need to have percentage of sulfur, 32 and 34. So these two percentage of sulfur length is actually different. Technically, guys, what's the meaning of this? Means we have two unknowns. Correct? The first unknown is the percentage of the sulfur 32. The second unknown is the percentage of the sulfur 34. And then the average is 32.1. So what I can do is I can label down this first. Okay, I will say that this is A, this is B. Okay, so A percentage and B percentage. Okay, something like this lah. Okay, so sulfur 32 percentage, I call it A. And then sulfur 34 percentage, I call it B. Okay, so so you can see from here. So what we do, okay, we say that we take percentage, multiply the atomic mass, cannot. So in a simple concept is, I take A multiply 32 plus B multiply 34 divide 100 equals to the final answer, 32.1. Okay, can Okay, so guys, but then if I write this out, right, you can't actually solve your problem with this. You can say, yeah, I got A and B, I just move all the numbers to the right side lah. I leave my A and B on the left. But if you think about it, guys, if you remember, according to maths, can you actually find two unknowns with just one equation? Cannot. So that's why you need to actually think about another equation also related to A and B, so that you can actually do simultaneous equation. Basically it's a maths lah. So what we can do from here is, we know just now this is your first equation. So how do we think about another equation? According to what we know, A percentage and B percentage is like the percentage for two different chemicals, right? But we know percentage maximum is 100%. So we can say A plus B is actually equals to 100. So with this, what we can do? Okay, guys, let me do the maths here first. I bring my 100 over. Here is 32A plus 34B equals to 3,210. Okay, I multiply 100 lah. 1, 2. Okay, like that. So what we can do is I can put the A plus B equals to 100. I can put like this: A equals to 100 minus B. Right? Then I substitute my A into my 32A, the A there. So I can put it 32 multiply 100 minus B plus 34B equals to 3210. Guys, expand this. I got 3,200 minus 32B plus 34B equals to 3210. So now you can actually put every numbers on the right, and then the one with B's on the left. So you see, negative 32B means like minus 32B lah, plus 34B. So our state here is 2B. Okay lah. So guys, if you don't know how you get to 2B, you do the maths lah. So negative 32 plus 34, because those are the one with B's, right? So you can left with 2B. And then in the 3,200, you also move the other side. You actually bring over minus, so you can say is actually 10. So guys, I don't know whether you all can brain or not. I just move everything to the right. Without unknowns, I move to the right. Those with B's, I leave it on the left lah. So now I can find my B is actually 10 over 2, which is actually equals to 5. And if this B is 5, I can substitute my B equals to 100 minus 5. I will say that A is 95% and B is 5%. Something like that lah. Okay, so guys, you realize that this type of calculation is where we actually have to think about another equation so that you can do simultaneous equation. So it's like a reverse way of doing. Instead of giving you percentage, they want you to find percentage. So you see F, okay, even I think this one is a typo lah. This is supposed to G. So F and G is actually the same topic but different way of doing it. F is a simple way lah. They give you percentage, they give you atomic mass, and then you actually do the average formula. Okay, just multiply plus together, divide 100, you get 10.8. But for last one, is basically giving you the final atomic mass, the relative atomic mass as your average. You have to reverse your calculation back to your percentage. A, what percentage, B is what percentage. Okay, so these are the stuff, okay, from here. Can I? So guys, this one is your first type of question for the day. Can I? So bring you guys some info back. Okay, then going down. Okay, question 1B. I do one more question for this one because confirm coming out one for this type of question, confirm coming out. So what is the meaning of isotope? Guys, again meaning of isotope is same proton number but different nuclear number. Okay, or same number of proton but different number of neutron. Okay, now state the pair again, guys. So which two is actually isotope? Same proton, 1717. So say X and Z. But give your reason, state the definition again. Okay, so you can see X and Z because X and Z have the same proton number but different nuclear number. Okay, then an isotope of Y has 8 neutrons, right? The symbol for isotope Y. So what's the meaning of symbol? Symbol means supposed to be the okay, guys, when you want to write something like this, symbol means you have to write the standard representation. Standard representation. Okay, which is basically the symbol out and then together with the proton and also with the nuclear. Okay, so now something like this. So you see Y. From here, Y got 8 neutron, isotope of Y. So if you take the 6 plus the 8, you get 40. Okay. So you see Y initially is 12, but now we say isotope of Y. Now your Y got one new isotope, which has 8 neutron. So you put the 8 plus the 6, you get 40. Okay. But the 6 remain because proton same. Okay, and then the diagram shows an object discovered by an archaeologist. Okay, so basically what is this? Oh, looks like a human. Basically it's bone. So from here, an isotope is used by archaeologists in his research. Name the isotope used. So what is used to actually estimate the age of a fossil and this and that. So we can say the carbon-14. State one use of radioisotope in industry means this is what we say. The sodium-24 for you to detect leakage. So that one is one of our answer lah. So you see, we stick to one answer. Industry stick to one answer. Okay, and then the graph besides shows the natural abundance of germanium. Okay, basically is another chemicals lah. State the name of heaviest isotope of germanium. Guys, also is germanium. I thought like what's germanium? Guys, there's a typo here lah. So it's germanium. So follow this one Okay, but doesn't matter. So which one so they want the heaviest isotope. So what you can do is look at the percentage. Okay, so 20.6. 37.4, 7.7, 37.6. Okay, take the largest number. So be from here, okay, you say that this is the natural abundance, and then what is the nuclear number? So we can say, oh no, they want the heaviest. Heaviest means the largest nuclear number. Wait, so this one is 70. Okay, so we say we start from 70 to 70, 71, 2, 3, 4, 5, 6. Okay, so it will be 76 lah. So we don't care about the percentage because they want the heaviest, means like the largest nuclear number. Nuclear number actually equals to the mass, equals to the atomic mass. Okay, so we say that it will be germanium 76. Okay, and use the natural abundance of each isotope to calculate the net relative atomic mass. Guys, basically what you do, percentage multiply atomic mass, percentage multiply atomic mass. I think this one is 72. And then percentage multiply 73, okay, 74, okay, and then got 76. Okay, so guys, you have to do the calculation lah. So it'll be something like this. Okay, so you see, percentage atomic mass, percentage multiply atomic mass. Okay, repeat the same thing for every atomic mass and every percentage, and then you can total up, divide 100, you get your average. Okay, and then going down on the other one. Yeah, okay, now we say figure 3 shows the information of boron. Okay, we have 10.81, 80% 11, 80% boron Y. Calculate the nuclear number of isotope. So guys, we'll be doing like multiple ways of like this atomic mass question, right? So this one is a third type. Okay, instead of looking for percentage or instead of looking for the final atomic mass, instead they ask you to find the nuclear number, which is the atomic mass, just for this one boron Y. Not the average, is the specifically just for this one boron Y, you want to actually find the nuclear number. So what we do, as we know, okay, according to our calculation, we take percentage multiply atomic mass, we take percentage multiply atomic mass, right? But then we are looking for the atomic mass for Y, right? So you do not have the atomic mass for Y. So what we can do, leave this as unknown lah. So I can say, so like 80 multiply 11 plus 20 multiply your Y. Okay, divide 100 equals to 10.81. This one is easier. Why? Because only got one unknown, which is your Y. Right now, so you can do the maths, bring over multiply 100, and then bring over a number minus, divide 20. Okay, so you get your answer, something like this. Okay, so you get like this 10.05. Okay, supposing I see. Yeah, so guys, so these are some basic info on how to do your atomic mass calculation. So got multiple type of questions lah. Got the easy one, just multiply, total up, divide 100. Okay, or the reverse calculation one. Okay, you want to find percentage, or like this, also consider the reverse calculation. You are looking for the specific atomic mass for a specific element, which is this boron Y. Okay, so nothing much here, guys. Just to go through a bit of samples we have in your calculation. So if these are okay, so there are more isotope questions at the back, you all can try it yourself. Next question they want to do is basically your heating and cooling progress. Okay, so if you try to go for the next page, page number 16, this one, page number 16, this one, okay, on question 2A, we can see from here that we have an experiment of what we do is we are actually investigating the melting point of substance S, but here they say it's naphthalene. Okay, but never mind, let's just go along with the question. Why is water bath used in the experiment? So guys, all the way back to chapter 2, this one I hope you all don't forget we don't heat the naphthalene or any chemical directly in the boiling tube, because if you heat directly without water bath, the bottom will melt first, then the top part will melt later. So which is something that is actually not fair. What we want is we want the top part, the bottom part, everyone melt at the same time. So water bath is here to actually make sure your heating comes in a very average. Okay, we call it the heating evenly. So see, water bath is just that the heating of naphthalene, you can say uniform, you can say even. These two words is fine. And one more thing is, you see, there are 2 marks, so we're gonna need one more mark where we say naphthalene is flammable. So water bath is there to like protect your chemistry lab so that you all don't die. Okay, and then what is the purpose of stirring substance S with the thermometer throughout the heating process from room temperature to 90 degrees Celsius? Okay, so we see when we try to heat, we're gonna stir. So why must stir? If you don't stir, what happen? So same thing lah. If you don't stir, inside, outside, okay, means this time we talk about up and down. But now if even with water bath, right, outside layer will touch the hot water first, then the inner part will melt later. So we don't want this to happen. We want to have inside, outside melt at the same time. So we try to stir it so that again you get a uniform heating. So you can see, ensure temperature of naphthalene is uniform. Again lah, uniform. Guys, all my students getting 9 A's and 1 B, and the B is Chinese. Ayo. Hey, who is this? Wait. Is this okay? I have this Elisa here. Elisa, are you the Elisa from Gasing? Is your sister Anna? Because I have students, these two sisters. No, all different Elisa. Many Elisa. Okay, but yeah, because I have student called Anna. Okay, she's telling me her result right now. No, or this is different Elisa lah. Okay, never mind. Okay, because I got Anna and Elisa. Okay, both sister very good. Okay, now the elder sister giving me her result. Never mind. Okay, so hopefully you all actually tell me your results when you all done with the SPM. Okay, so now moving down. Okay, if substance S is replaced with Q, okay, I think the S is still the chemical here lah. That has melting point of 109. Okay, so guys, we don't even need to know what is Q, but they already tell you melting point of 109. Is water bath suitable to be used? Cannot. Why? Because water maximum can go until 100 only. If you go over 100, what happens to water? It will boil and then become water vapor, become steam. And then your steam cannot actually continue heat your chemical until 109. So maximum 100, then your water boil, then nothing gonna continue heat your substance Q. Correct? So we can say they ask, okay, the first thing they ask you is this suitable? So the first answer is say no. But why? I say from here no. Hey, where's my guys? Where's my explanation? Oh, wait. Is or explanation at the next one. But why the no give you 2 mark? Okay, guys, I think the no only deserve 1 mark. This one, I think typo. Okay, the no deserve 1 mark. And then why? Explain why. Okay, that one deserves 2 marks. Okay, because you say water bath. Okay, your boiling point of water is 100. So the melting point of Q is higher than the boiling point of water. Or if you just want to say the melting point of Q is higher than 100 degrees Celsius, also can. So these are the different ways of giving you the answers. Okay, and then going on, the natural abundance of copper is 69.17%. So guys, same as just now. So here you got percentage, got atomic mass multiply percentage, atomic mass multiply percentage, divide 100. So I think this one is a similar question. Just do the same. Okay, divide and look for the average. It's fine. That's easy lah. Okay, then given that the relative atomic mass of thallium, okay, it consists of thallium 203, 205. Is 204.4. Again, guys, this is percentage, guys. For this one, I don't want to go through already because it's a reverse calculation again. Okay, where you actually have the atomic mass and atomic mass. Okay, but they ask you to find the percentage. So it's a reverse calculation where you have to look for the two equations and then do simultaneous equation and then look for your percentage. So this one, B2, I leave it for you guys to give you a try. After seminar okay, so this one I did one time with you guys already. So this one you all just leave it for yourself to do your self practice And then going down, see how many protons and electrons are there in lithium ion. This one, guys, this is the question that is very tricky in exam. Why I say so? They ask you how many proton electron are there in lithium ion, and they tell you proton is equal to 3. Guys, do you realize that they give you answer already? You're gonna be like, teacher, they asked me how many proton, then they give me proton number of lithium is 3. So proton just 3 correct? Guys, yes, proton just 3. Follow this, whatever they give you from here. Proton is just 3. But electron, is it still 3? You look at a small hint there. Yeah, do you see they say lithium ion? What does ion stands for? Ah, very good. Okay, how did lithium got this positive charge? So if you remember in chapter 4, your group 1 element, remember lithium, okay, initially is 3 proton and 3 electron, right? But if I write down the electron arrangement, it's 2.1. Correct not? So what happened is how he turned from lithium to lithium ion, he have to do something to the electron. So what something he did to the electron? He actually throw this electron away so that it turns into lithium ion, which is 3 positive proton and 2 electron. So he throw the electron away. That's why he left with 2 electron and he get 1 more extra proton, which is a positive charge. So in exam, guys, please read carefully what number of proton and electron that you are looking for. So the point is check the particle very carefully. Sometimes they ask you proton electron of lithium atom. Atom then no charge. They ask you something ion, then got charge. If got charge, you have to check the difference between your proton and your electron. Then only you actually give them the answer. Okay, now because in exam, a lot of people like, oh teacher, proton is 3, then electron also 3 lah. So 3 and 3 means they never read the question carefully. They forgot to actually focus on the type of particle. If they are actually ion, be careful on this. Okay, if it's atom, then very easy lah. But if it's ion, this is where all the students get wrong. Okay, so be careful on this in exam. So of course, you see proton 3, electron 2. So these 2 marks actually very easy to get one. Just that I scare you all careless mistake lah. You all think, oh, you're so easy. 3 and 3, and then you get wrong for one of it. Okay, so if this one okay, moving on. Yeah. Okay, so next one. Okay, it's a heating curve. They say melting point and boiling point is -182 and -162 respectively. And then they plotted the heating curve of methane as shown below. Okay, so now label temperature X and Y. So guys, you see when the graph go up, how it goes, you see. They say got melting point and boiling point. So which point is melting? Which point is boiling? So obviously, guys, if the graph is going up, the chemical must melt first, only can boil. So I will say X is your boiling point, then your Y is your melting point. Okay, so you're all okay with this? Okay, but what is the temperature? What is the temperature for X? What's the temperature for Y? So according to the two numbers we have here, one is -182, one is -162. So you go from low to high. So which one is lower? I will say the -182 is your Y, while your X is the -162. Okay, so this one. So just put in words like this, that's okay. And then state the state the physical state. Guys, what is physical state? Is it solid? Is it liquid? Or is it gas? But guys, don't just limit yourself to these 3. Because why? When they are having constant temperature, the physical state is a mixture. So let's say for P and Q, guys, since Y is the melting point, right? P and Q means not yet melt. So if not yet melt, it is a solid. So correct. So from here, you see solid. Okay. But how about R and S? So R and S, you see, R and S is still going up, right? So it's actually like after melted, but before boiled. So what is after melted, but not yet boiled? Liquid. See? Yeah, so R and S is after melted, but not yet boiled. But the last one, you see, S and T. Where is S and T? S and T is like halfway through boiling. Like you see, in the middle of boiling, right now. So in the middle of boiling, it's not fully boiled yet. T to U only fully boiled. S and T is not fully boiled. So if it's not fully boiled, what is the physical state? For those who boiled, it's gas. Those who haven't boiled is liquid. So that's why S and T is a mixture of liquid and gas. So from here, mixture of liquid and gas. Okay, and then on the other hand, you see, describe in terms of the motion and distance, the behavior of methane particles at region TU on the graph. Guys, means what we're going to talk about is the motion, the distance. Okay, so on TU, okay, what's TU? TU is like totally boiled, fully boiled. It's totally gas lah. So if you guess, guys, how gas particle move, because we talk about motion, gas particle move freely, randomly, very far apart. Remember? So correct. Randomly, freely, and very far apart. So these are the keywords, correct? So say very far apart, and then freely, randomly. So these are the keywords. Okay, and then draw the arrangement at of the particles at negative 182. Okay, at negative 182, it's like the process of melting. Means it's not fully melted, or it's actually already it's also started melted already. So it's actually what? So at negative 182, it's like solid, a bit solid, and then a bit liquid. So how to draw a bit solid, a bit liquid? How to draw? Because you all know solid is like closely packed, okay, nicely arranged, and then liquid is like further away already, and then it's like random arrangement. But how do I draw like half solid, half liquid? Very simple. Imagine that you have a box. Half of the box solid, half of the box liquid. So how do we draw something like that? This. Okay, you see, this part is actually still closely packed, solid. And then this part melted already is liquid. Okay, so something like this. Okay, and then explain why temperature of methane remain constant from Q to R. This is to R. Q to R. Okay, so for Q to R, what happened is, you see, is actually melting halfway. Okay, so they ask you why during melting, the temperature don't go up. So this is also a very common question for heating and cooling curve. Every time, if they ask you heating curve or cooling curve, confirm they're gonna ask you why constant temperature. So for heating, got his own answer. For cooling, also got another answer. Okay, so for heating, what's the answer for heating? Means that when you are actually melting, even though your fire is still there, okay, your fire, the heat energy is still supplying. We are still actually still supplying energy. Your chemical also still absorbing energy. But why he absorb energy, but the temperature never go up? Because he absorb energy to do something else. So what is the something else? Very good. Is for you to overcome the force of attraction between particles. So from here you see, energy absorbed is used to overcome the force of attraction between particles, so that the liquid, so that the solid turn into a liquid. Okay, so there are students who are actually trying to say to question my result. Teacher, you got get A plus or not? Okay, send them my results. Okay, so now next one, we have another one, which is the cooling process. So it's a reverse process of just now the heating lah. So now what is meant by freezing point? Again, guys, this type of definition are also possible in your exam. Okay, so that I ask you like, what is the meaning of freezing? Say, teacher, I know freezing is what liquid becomes solid. Good idea. Okay, this is the point. But then of course you have to write in a full sentence lah. Okay, so we have to say that it's a temperature. Okay, a constant temperature which liquid changes to solid at a specific pressure. You must mention this constant temperature and specific pressure. Okay. And why temperature remain constant during freezing? Just now we did one question for heating, right? So now cooling down, when you're freezing, also same thing, got constant temperature. Why then? So the answer will be totally different. It's not for you to like overcome the force already. Now guys, if we say we absorb heat to overcome force, so now if cooling down, with the balik, heat energy release, and then for what? For you to like form back the force of attraction. Like you're gonna join back the force of attraction. But it's not that easy. You're gonna mention like two words. You see, So we say from here, you see, heat loss to surrounding is exactly balanced by the heat energy release as the particles attract one another to form solid. So why need to write in this word? Or what's the meaning of this sentence? Because when we say heat loss to surrounding is exactly by actually balanced by the heat energy release as particles attract one another, right? It means that just now we say we absorb heat to overcome force, right? So now if you want to form the force back, okay, we want to form the force back, it's supposed to release heat kind of. So with this concept, okay, this heat energy release is your temperature increase, because when something freezing, you release energy out, kind of. And because when you're cooling down, you're supposed to like have a low temperature around us, kind of. So we say that heat loss to surrounding, this is actually temperature going down. Temperature decrease. So one temperature decrease, one temperature increase, so they balance off each other, then they become a constant temperature. So heat loss to surrounding is basically cold, like cold temperature around you. Like I put it into fridge. The fridge is cold temperature, so temperature go down. But then when something freeze, you release heat, temperature go up. So one go down, one go up, balance off. Then you get a constant temperature. Okay, and draw the cooling graph. The temperature increase is the surrounding temperature increase. You mean the surrounding temperature increase. Because what thermometer measuring is the temperature of the surrounding. Like when naphthalene cool down, he freeze, he will release heat to outside, but he release heat to where? To the thermometer also. Okay. So imagine a thermometer, okay, you put into fridge, he cool down, temperature decrease. But then when the thermometer is like put into something that is freezing, that something freezing will release heat out to the thermometer. So increase the thermometer temperature. So one decrease, one increase. Then it will actually balance off. Okay. So now draw the cooling graph. So basically, guys, you draw the reverse version of no, this is methane. Okay, this is methane. So we draw cooling graph lah. So it means you have to draw like curve, go down, straight line, go down, straight line like that. So you draw the something like this. Okay, so you have P, Q, R, S. Okay, don't have the label, guys. No labeling is actually needed. You just need to actually state the temperature. Okay, and then temperature also no need actually, because they never mention temperature. But even because if you know, naphthalene actually melts at 80 degrees Celsius, so it also freeze at 80 degrees Celsius. But I think this question they lack of information. So they're supposed to give you the melting point, then you can use the melting point also as your freezing point. Okay, so 80 is something that's supposed to be provided by question lah. But I think I think you can copy paste wrong already. I can see like E and become A. I think something that he never update. Okay, some mistake from here. Never mind, guys. Exam confirm got give one. Okay, don't worry about that. Okay, so guys, done with the drawing. Okay. Oh, guys, my SPM result is out. It's time for me to register my SPM for this year. I was waiting for the results, man. They don't want to let me register because they say must wait the result out first. Where's my Akang Giliran? Yay, I can register. Yay. Yay, I can register for my SPM this year already. Okay. Let me try. Later I try lah. Okay, so guys, after the heating and cooling curve, okay, so I try to move on with another type of question here lah. So there are more questions at the back. Okay, you all can try yourself later on. Okay, now go to let me see. Okay, straight away for question number page number 20. This one. Page number 20, where we have your empirical formula. We start to go into chapter 3 already. So chapter 3 got many calculations, and the two topics that is very important is your empirical formula and also your stoichiometric calculation. Okay, so I do empirical formula first lah, because empirical formula got two type of experiment. One is this copper oxide powder, and then the other one is the magnesium oxide, the one with the open and close the lid one. Okay, so what is meant by empirical formula? So guys, as we mentioned, empirical formula is the simplest ratio. Like you see, copper oxide. Copper oxide is CuO. Why not Cu2O2? Why not Cu3O3? Correct. So everything is actually in the simplest version. So we say that it shows the simplest ratio of atoms for each element in a compound. Must. All the highlighted word, guys, highlighted word must include in your exam. Okay, you cannot say, teacher, can I just stop at simplest ratio of atom? Then I full stop? No, must say for each element in a compound. Okay, and then how do you dry the hydrogen gas? Okay, guys, I think this one, yes, the moment I see this question, I know that again, Yutian, he never actually update the question. Guys, so B, you all cancel this for me, okay? Because we no longer dry the hydrogen gas anymore. Because this is a new version, a new setup, right? That we don't have to dry the hydrogen gas. We just let the hydrogen gas flow through the heating. The hydrogen gas eventually just gonna dry off. Okay. So don't worry about that. So this question not gonna come out in future anymore. Okay, so this question is only applicable for the old version. Okay, the old version empirical formula for copper oxide. Okay, but nowadays you all use the new version already lah. You all don't use the old version anymore. So for B, you all just cancel off. Not gonna do B. Okay, C. What is the purpose of using zinc granule and hydrochloric acid? So guys, remember what is the purpose of having zinc and HCl? So if you know, okay, they ask you to write the equation. You see, what is zinc? Zn. What is HCl? Okay, guys, I give you the answer. What is hydrochloric acid? HCl. Okay, and what happened is your zinc will go in and kick off the H, snatch the chlorine, snatch the girlfriend, becomes ZnCl2, and releasing out hydrogen gas. So you get a balance equation. You get something like this. So the purpose of doing this zinc and hydrochloric acid is basically to release out the hydrogen gas. If not, where you get hydrogen gas? Okay. So from here, we said that is to produce hydrogen gas. Okay, and then what change can be seen after oxide of copper is heated strongly? What is the original color of CuO? If you all forgot about the color, CuO originally is actually black color. But then after your reaction, what happens is the reaction is CuO, after reacting with H2, now is the turn of H2 go and snatch paper girlfriend. So you see it become H2O, no, then the Cu no more girlfriend, right? So this is originally black, but after reaction, your copper is actually brown. Okay, so we can see that You can say black solid turns brown. Okay, and then the next will be your calculation. So where you're gonna actually, okay, usually in the exam, right, they will always give you the results, okay, in your experiment. And then what you're gonna do, you're gonna actually take the mass of them and then try to actually do your empirical formula calculation. So I believe all this you all can do yourself, but I try to do one time with you guys. So how to get the mass? Okay, because if you want empirical formula, you're supposed to find the specific mass for just for every atom. Let's say for here we have copper oxide. You're gonna look for the mass for just copper and also the mass for just oxygen. Okay, now. So if you have mass of copper, how to find it? So I will say that. Okay, if I want mass of copper, is this one mark? I need to minus off the mass of combustion tube and also the mass of asbestos paper. So I can take 147.95. So I label 1, 2, 3. So I will say that for to find mass of copper, I'll take 2 minus 1. Okay, so this is the trend. But if I want the mass of oxygen, which is this one, just the oxide, so I need to have to cut off the mass of combustion tube, minus off the mass of asbestos paper, together with the mass of copper. So which one? I will take 3 minus 2. Okay, something like this lah. So I take 2 minus 1 to get copper mass, 3 minus 2 to get the oxygen mass. Okay, so you can see from here that you get something like this. Okay, so once you have this, how do you find number of mole? The formula that you all learned before, mass over molar mass. So you take mass over molar mass, mass over molar mass, and molar mass provided by the question, guys. Don't have to think about it yourself, don't have to memorize it yourself lah. So take a mass over molar mass and you see the same number, ratio is 1 to 1, so you get CuO. Okay, something like this. Okay, so of course, guys, this is something very easy in your empirical formula. Okay, and write the balance equation. I actually gave you the answer on the top lah, which is the copper oxide plus hydrogen gas. So yeah, the hydrogen snatch the O become water and actually copper. So it's something like this. Okay, and it's already balanced. Okay, this is the good news of it. Okay, and why does hydrogen gas need to flow continuously for a while before starting the heating process? So guys, this one we have before you actually you start burning your ethanol and heating the copper oxide, you're gonna let your hydrogen gas to fill up the tube first. Okay, why? Because if you don't fill up the tube, the tube inside got oxygen like the normal air. So got oxygen, and then your hydrogen come, okay, and then you heat oxygen, hydrogen, heat together, you will get explosion. So you only want H2 inside the tube. I don't want the O2 H2 explosion. So from here, we say that so you have to remove all the air in a glass tube. Okay, if not, you will cause explosion. So that will be the concept for it. Okay, and then can empirical formula of magnesium oxide be determined by the same method? So can we do this method for magnesium oxide? Cannot. Why? Because if you change your CuO, if I change this equation, I change it to change from CuO to MgO. Can your H2 snatch the oxygen out from MgO? Cannot, because Mg is more reactive than the H2. So H2 cannot take away the O from Mg. The reason why H2 can take away the O from Cu is because H2 is more reactive than your Cu. So from here, okay, we're gonna say no, because magnesium is more reactive than hydrogen. And this is the reason why we have two different experiments. If you want to do for magnesium, you have to do the open and closed lid. Okay. If you want to do for copper, then you have to do this experiment. Okay. If not, you can do the same experiment for everyone, right? But for now, we realize two different experiments for two different reasons because of the reactivity. Okay, and the hydrogen gas is allowed to flow until the product of heating at room temperature. Means that even if you done experiment, you don't remove all the tube, okay, you don't like unplug everything, okay, instantly. Why? Because if you actually unplug, your hot copper might react back with the oxygen in your normal air, then turn back to copper oxide. So what you do is, after you're done with the experiment, after you see everything done already, you're supposed to leave it there, let it cool down, okay, until room temperature. Only you unplug everything. Okay. So this is actually there's the concept for it. So to prevent air from entering the apparatus, because you react with the hot copper to form back the copper to oxide. Okay, this is something that you want to avoid. Okay, and why do heating, cooling, and weighing process, guys? This is something that you all don't do in real life, but in your exam you must do lah. What is the meaning of heating, cooling, and weighing? Means that you see, guys, have you wondered how we get all this mess? How I know like how long I heat to get the mess that I want? Do I heat for 5 seconds? Do I heat for 5 minutes? Do I heat for 5 hours? Which one do I? How long do I heat to know my experiment is done? Actually, we don't take your time as your result. What we do is we have to repeat the experiment. We heat and then we cool it down and then we measure the mass and then we repeat again. Heat, cool down and then weigh the mass until the mass don't change anymore. Why? Because I say if you heat, cool down and weigh, heat, cool down and weigh, your two experiment result is different mass. If your mass is still changing, we don't care whether is it increasing or whether is it decreasing lah. As long your mass is still changing every time you repeat the experiment, means that your mass is not the final answer. So you have to repeat, okay, you have to repeat your experiment until the mass don't go up, don't go down, only the mass is considered constant, only the mass is considered your final result. So we have to say that to ensure all the copper oxide are completely changed to copper. If your mass is still decreasing, means got still some of it is copper oxide. You're gonna heat, repeat, repeat of your heating, cooling, weighing until your mass decrease until one point, you keep repeat but your mass still remain. Then you know your experiment is done. Okay, your reaction is complete. Okay, so this is your empirical formula for your copper oxide. So one question on this, and then I do one question on the magnesium one. See. Okay, so one question on copper oxide and one question for magnesium, which is on page number 22. This one. Okay, so on page number 22, you see, this is the experiment where we actually burn your magnesium, not burn, we heat your magnesium ribbon, and then it will react with oxygen, become magnesium oxide. So the concept will be something like this, okay, Mg, heat directly with oxygen, you get MgO. Okay, but it's not balanced, you have to balance equation. So the point is, why we do this for magnesium oxide? Because magnesium is quite reactive. He can be directly heat to react with your magnesium and to react with your oxygen. But copper cannot do this because copper very low reactivity. You cannot heat copper directly with your oxygen and then you get a complete reaction. So that's why you see two different method, two different experiment. So again, guys, what is the meaning of molecular formula? Oh no, guys, that's how we asked about what's the meaning of empirical formula, right? We wrote the definition for empirical formula is something about show the simplest ratio of atom for each element in a compound. But what is molecular formula? Everything the same, but you change the simplest ratio to the actual ratio. You see, show the actual number ratio of atoms of each element in a compound. So do you see the definition for empirical and molecular is everything the same except for the simplest ratio? You change to the actual number of ratio. Actual number. Guys, even my parents is asking my SPM result. Hello, why you all have no confidence with me? Aiya. Okay, so besides having another definition, okay, so the calculation is almost the same now. So you take if you want to get the mass of magnesium only, you take 29.7 minus the first one. If you want to get oxygen only, you take the last one minus the second one. Okay. So of course, guys, you're just gonna move on with the calculation. Okay, show you mass over molar mass, show you the ratio 1 to 1. Okay, you get MgO lah. So the good thing about these two experiments is CuO and MgO is both 1 to 1. So in exam, even if you don't know, if you really don't know how to do that calculation, you can predict the final answer. Confirm 1 to 1. Cu and O 1 to 1, Mg and O is also 1 to 1. Okay, so that's a shortcut lah. But I think it's not that hard. Okay, so just do a calculation. So the final checking of your answer is always 1 to 1. Okay, if you calculate out, you get 1 to 2, 2 to 1, something wrong. Okay, must be 1 to 1. Okay, so that's a short hint for your MgO and CuO. And write the chemical equation. I gave you the answer on the top. Okay, so you can get your Mg plus O2 become MgO and then the balance equation. Okay, and why was the crucible covered with the lid as soon as the magnesium started burning? Okay, this is all the common question, guys. You see, like copper oxide got their own precaution question, and then magnesium oxide also got their own precaution question again. So depending on which question come out in the exam, be careful. Every experiment like this, they have to ask precaution one. Okay, so why we need to like cover the lid as soon as the magnesium start? So if you don't cover, you open, the magnesium oxide is a white powder. So this white powder will fly away. It will escape. So we can say that is to avoid the white film from escaping. Okay now. But then why we need to open it is to allow oxygen to react with the magnesium. So you cannot just close it all the time. If you close it all the time, oxygen not enough. Okay, so this is actually this is actually something you have to know. You have to open and close for a reason. And why this method is not suitable for copper oxide? Because as I said, guys, this one is direct heating, right? Copper is not reactive enough for direct heating. So you can say that copper is less reactive towards oxygen, okay? And it's a very slow reaction. Okay, and going down, explain on how to ensure the reaction has completed. So guys, to make sure reaction complete, no matter which experiment, same answer, which is what just now I said, how do you know experiment is done? Repeat your heating, cooling, and weighing process until constant mass is obtained. So you have to say something like this, okay? Heating, cooling, and weighing process are repeated until constant mass is obtained. Constant mass is what, like, no matter your mass is like decreasing or increasing since the beginning, as long your mass is changing, and then you keep repeat heating, cooling, weighing until your mass don't change, then we know it's basically done with the experiment. Okay, at least 2 precaution steps that must be taken during the heating process. So for heating for magnesium, right, there's not much precaution, not as much as your copper oxide lah. So the 2 precaution is you have to open for certain reason, you have to close for certain reason. That's all. Okay, so you can say that lid must be open at intervals to allow oxygen gas to enter and react with oxygen with the magnesium. Then you have to quickly cover again to prevent your white film from escaping. So these are the common precaution for your magnesium. Okay, but copper oxide got many precautions. Remember the copper oxide got you have to flow your hydrogen gas for 5 minutes, okay, before you start a reaction. Even if you end a reaction, you have to flow, you let it cool down until room temperature. Okay, so I would say copper oxide is the hard part. Okay, copper oxide is the harder one. Magnesium oxide is the easier version. Okay, so guys, this one can all good. Okay, so guys, after done with all these topics, right? Right now the last half an hour is where we're gonna do the last topic of this chapter. It's called a stoichiometric. So stoichiometric calculation, right? I would say is quite hard in the beginning, but eventually when you go along with it, you're gonna get used to it. So now then you can actually get the calculation easily lah. What's the use of magnesium oxide? You mean in real life? Magnesium oxide? Uh, or you mean uses of magnesium oxide in lab? Or you want the use of? There's a question for 5B. Oh, you mean the next one lah? This one 5B So this one, 5B. Oh, you mean this one lah? Wait. Okay, so this one magnesium oxide. Or in real life lah, yes. For because magnesium oxide is alkaline, so it's actually for your gastric pain medicine. Gastric pain. Magnesium oxide. Because if you know, have you heard before there's a milk called the magnesium milk? Okay, if you drink like normal milk, right? But then there's a type of milk, right, called the magnesium milk for people who have gastric. For you to like, for people who have gastric, when they drink the magnesium milk, it can like relieve the pain of gastric pain. So technically magnesium oxide is the chemical that we add into your milk to form this thing called the magnesium milk. So it's for basically for your gastric, to relieve gastric pain. So we call it the antacids medicine. It's actually anti-acid lah. Anti-acid, is it? It's a short form for anti-acid. Okay, so this one done already. Okay, so guys, as I mentioned, okay, last part I want to do is your stoichiometric calculation. Okay, so stoichiometric calculation is something around page number 26. Okay, page number 26. Okay, so we have some K-bar question like this lah. Even though you all say, "Wow, teacher, what is this? We never learned before." Guys, don't worry. They will ask you questions that you learned before, even though they give something very, very complicated or very weird. So we have seen like paracetamol commonly used medicine that can treat your pain, relieve pain, reduce fever, and then again. So now, it's typically used to relieve mild or moderate pain, such as headache. Okay, so all the common knowledge. Adult can take two 500 milligram tablets at 4 times in 24 hours. You must wait at least 4 hours between doses. So do not take more than 8 tablets in 24 hours. Okay, so all this information and they give you the atomic mass and also all the you see the Na, the Avogadro constant. So what is the chemical formula for paracetamol, guys? What's chemical formula? Like you see, magnesium oxide is MgO, copper oxide is CuO. Okay, got many like we call it the chemical formula, which is the symbol for all the chemicals lah. So what you can do, even though you do not know what's paracetamol, but do you see the diagram they give you? Just count and total up everything you have, and then you know it's a paracetamol chemical formula. Okay, so what you can do is you can count your C. C is 1, 2, 3, 4, 5, 6, 7, 8. So C8. Okay, and then how many H? Will be 3, 4, 5, 6, 7, 8, 9. So like H9. Okay. Then your oxygen will be 1, 2. So O2. And then N is the only one N. So it's N. It is so C8H9O2N. The sequence doesn't matter, guys. Sequence just go along. Okay. And what is the relative molecular mass of paracetamol, guys? What's molecular mass? Means the molar mass, right? How are you gonna do? Total up the molar mass of all the atoms right here. So you can see like C is 12, and then H is 1, O is 16, N is 14. So you can see I can put something here. So I can see like, see 8 times 12, H times which is 9 times 1, and then N is 14, and O2 is 16 times 2. Okay, so these are the things we have. Total up, you get 151. And what's the molar mass of paracetamol? So guys, basically what you can get from here, your atomic mass is basically also your molar mass. But the molar mass actually have a unit called the gram per mole. Okay, even if you don't put a unit, it's fine also. Okay, so you just say 151. So just to let you know, guys, what's the point of B and C? Is to let you know that molar mass is equal to your molecular mass. Okay, and calculate the number of paracetamol molecule in 500 milligram tablet. So guys, how do we actually do this calculation? So first thing first is here, the value they give you is 500 milligram and is a unit for gram. It's a unit for mass, right? So if they give you the unit for mass, what can we do? We're gonna try to relate to the first thing first is to convert your mass from milligram to gram first, because we don't use milligram in your calculation. So we convert it to mass to gram first, which is if you all didn't know, 1 gram equals to 1000 milligram. Okay, so you just divide 1000, you get 0.5. Okay, and then going down, how do I start my calculation? Since they gave us mass, we start with mass over molar mass. So you can say number of mole equals to mass over molar mass, which is the mass 0.5. Molar mass calculated in in your B, so you say 151. You divide, you get this number as your number of mole. But what they finally want, they want to actually get you the number of molecule. Guys, molecule belongs to which formula? Molecule actually belongs to the number of particles. Why? Because particles will actually contains atom, ion, and molecule. So if they ask you to look for number of molecule, you're looking for number of particles. So what you do, use the number of mole equals to number of particles over Avogadro constant. You can see this is the formula where we say number of mole equals to NOP over NA. Okay, so you see, I'll put in my number of mole. Okay, put in my number of mole and then my Avogadro constant. Okay, multiplied it, you get a number of molecule, which is this number lah. So guys, just a simple concept here right here first, because we are actually just doing what, just to get you guys familiar with your formula. So what are the three formula? Remember again, number of mole equals to mass over molar mass, volume over molar volume, number of particles over Avogadro constant. Okay, make sure you all familiar with these three formulas. You need to know when to use which formula. This is very important. Okay, but then next one is calculate the maximum number of mole of paracetamol can be taken by adult. That's a bit OCD. By an adult. Okay, the English not very good. Okay, so now, so if you go up, you see, they say maximum number of mole of paracetamol. Okay, so what's maximum? 4 times in 24 hours. Do not take more than 8 tablets in 24 hours. Okay, so 8 tablets will be the concept lah. Okay, so he can take 2. Okay, so each tablet is 0.5 gram now. So if it's 8 tablet, so you're gonna multiply 8 lah. So you take the 0.5 multiply 8. So this is the maximum gram that you can take for your paracetamol. So you can see from here, what we can say is take this number of mole, and then you multiply 8. Okay, then this is the maximum number of mole then of your paracetamol. And moving on, determine the mass of your 0.15. So if you give you number of mole, how do we convert to mass? Use mass over molar mass, but different calculation lah. So we say number of mole equals to mass over molar mass. Okay, number of mole is 0.15, and then molar mass is 151. So how do you find mass? Multiply the 0.5. Okay, so you get this as your mass. So this question basically is a simple go through on what we have for our mass over molar mass and different calculations lah. So just a brief go through. Okay, so guys, this one hopefully you all still have it in your memory. Okay, later on I'll do some hard question. Okay, so now let me do some harder questions. Okay, something around. Okay, around page number 34. Okay, guys, look at this, page number 34. Okay, something like this. Okay, when they give you equation, okay, sometimes if they don't give you equation, they ask you to write your own equation, also possible. Okay, so for 34, question 9a, is the question gave you equation where ethanol burns in air, and then they burn it to form carbon dioxide, and then to form water, and it's already balanced. You see the number there? Balanced already. So that's the good news about it. And then if they say if 9.2 gram of ethanol. So guys, who's the ethanol? So as we say, ethanol is this one. So this guy is 9.2 gram. This is the mass. Okay, not? And they ask you to calculate the volume of carbon dioxide. So who's the carbon dioxide? This guy. They're asking you to find volume of carbon dioxide, which is basically we are looking for the volume of this CO2 lah. So how do I do the 3-step calculation? Okay, why do I say need 3 steps? Because we all say, teacher, I see here got mass. I use mass over molar mass lah. So I think the first step is the easiest thing lah. You have to find number of mole first, where I have mass given with mass. I start with mass over molar mass. Okay, but don't forget, guys, molar mass also need to total up the atomic mass for all this, right? Okay, so you have to do the mass from here. You see, so you see your C2H5OH, the atomic mass is 12 times 2. Okay, H times 5 is 1 times 5 plus 16 plus 1. So you all do the calculation lah. Okay, so 24 plus 5 will be 29, 30, so around 46. So this is the molar mass of your alcohol. So that's how you see from here. I take 9.2 over the 46. 9.2 over 46, you get your 0.2 mole. So what happened here is you get the number of mole. It's for the ethanol. You see this number of mole is for ethanol only. Okay. So if you want to find volume of carbon dioxide, you suppose that you need volume. You need the number of mole of carbon dioxide gas. So the point is, if you say, teacher, I know here got I want to find volume. Isn't it we go and use number of mole equals to volume over molar volume? Yes, this formula is correct, but you are not allowed to use this number of mole here directly. Why cannot use directly? Because even though they are both number of mole, but they are for different chemical. This 0.2 is for the C2H5OH. While if you want to find volume of CO2, you're gonna need number of mole of CO2. Do you have number of mole of CO2? Don't have. If you don't have, how are you supposed to find? Use your ratio format. What is ratio format? So basically, you see, what is the ratio between your alcohol and your carbon dioxide? You check the number in front of them of your balance equation. Is there any number in front of ethanol? Don't have. So you have something like this. You see, like C2H5OH compared to the carbon dioxide. Okay, see, I'm comparing what I have, which is a C2H5OH, comparing to what I want, which is a CO2. So according to the ratio, I have 1 C2H5OH, but you will produce how many CO2? You see the CO2 in front of the 2, right? So I have 2 CO2. So according to the ratio, if my ethanol is 0.2, then what is my number of mole of my CO2? You follow the ratio lah. So 1 to 2, then you're 0.2. Now we'll get you 0.4. Okay now. Then only with this 0.4, that is the number of mole. So this is number of mole of CO2. Okay. Only with this number of mole, you can use in the volume over molar volume. Okay. So why I write here then? Because some teacher, right, they will insist on writing sentence. So if you write something like this lah, you see like from the equation, 1 mole of C2H5OH produces 2 mole of CO2. Okay. Therefore, 0.2 mole of C2H5OH produces 0.4 mole of your CO2. Correct? So you see, this sentence, these two sentences is the same meaning as this ratio. Okay, some teacher accept ratio, you all go with ratio. Some teacher don't accept ratio, some teacher want to go with the sentence, you all follow the sentence lah. Correct? Okay, so you all stick to this sentence if your teacher wants sentence. Okay, so once you have this number of mole of your CO2, then you're gonna move it on the other hand. Okay, you try to find your volume of CO2. Okay, so finally I will have this volume over molar volume. The 0.4 comes into play, and then 22.4. Where I get 22.4? The molar volume given by question. So put it in and then multiply, you get the 8.96 dm³. Okay, so these are the concepts that we can actually see from here. So these are the 3-step calculation, and this is the basic steps of your stoichiometric calculation. Okay, very, very important. Your coming exam confirm at least one question. You can go more than one, it can be two, can be three, okay, different for different chemical. Okay, so of course, this is what we have for number one. And then number two is calculate the volume of oxygen needed at for reaction. So guys, now they want the volume of oxygen. So something different. They want volume of O2. Okay, the green color one. What we can do, you can use the number of mole from your ethanol from the previous question. You can use a 0.2. But now your ratio, you ratio to the O2. You don't ratio to CO2 already. Now since you need O2, okay, you need O2. You ratio your C2H5OH to your oxygen gas. So instead of C2H5OH to CO2, I ratio C2H5OH to O2. So the ratio is 1 to 3. How I know 1 to 3? There's no number in front of C2H5OH, but there's a 3 in front of your O2. So with this 1 to 3, we can actually say the sentence like this. 1 mole of C2H5OH react with 3 mole of oxygen. Okay, therefore 0.2 mole. Okay, you react with 0.6 mole of O2. So you see 0.2. Okay, ratio out, you get 0.6. Okay, like this. Okay, so once you get 0.6, how do you convert to volume? Same formula, volume over molar volume. Okay, so that's why you're gonna get something like this. Okay, 0.6 multiplied with 22.4, you get 30.44. So I would say, guys, the steps are no difference. No difference in the steps, just that different chemical. So we have different ratio and slightly different number. You get slightly different number of your volume. Okay, so just to clarify all these things, remember, be careful for this. Okay, but of course, in exam, right, is it possible they don't give you any equation? Also possible. See, 8 grams of magnesium oxide powder react with excess aqueous nitric acid to produce magnesium nitrate, salt, and water. Write a balanced chemical equation for the reaction. Guys, first thing first, what is magnesium oxide? Magnesium oxide, guys. I believe I hope you all still remember. Magnesium inside is Mg2 plus, oxide is O2 minus, so it's MgO. Okay, and then what is nitric acid, guys? Memorize formula for nitric acid or not? Confirm don't have. Okay, nitric acid is HNO3. And then they say produces magnesium nitrate and water. Okay, I believe water you all know lah, H2O. But what is magnesium nitrate? Again, it's an ion, Mg2 plus. What is nitrate? NO3 minus, guys. Do you all memorize all these charge, all these ions? Confirm don't have, right? Start to memorize. So once you can memorize this, you can write out the symbol. Magnesium nitrate is Mg, NO3 bracket 2. With water, H2O. Don't forget to balance equation. Okay? And don't forget balance equation. So you're gonna get like 2HNO3 and then right. And then what else? Is it enough? I think it's enough. 6, 7. Okay. 2HNO3 is your answer. Okay, now calculate the maximum mass of magnesium nitrate formed in the reaction. Okay, so first of all, they give you information for which chemical? They give you information for 8 grams of magnesium oxide. So I will say this guy is mass 8 grams. Okay, and they are asking to look for what? The mass for magnesium nitrate. So again, it's still for mass, but they are looking for the mass for another chemical. So what do we do? Again, the 3-step calculation. Step number 1 is what? Step 1, start with the number of mole. Okay, what is the only number they give you? The 8 gram, right? So you can say number of mole of magnesium oxide is mass over molar mass, 8 gram. And what's the molar mass for magnesium oxide? MgO, 24 and 16. So it'll be 24 plus 16. Okay, so total out 24 plus 16 is 40. 8 over 40 is 0.2, I guess. I don't know. Long time never use my brain to calculate stuff. 8 divide 40. 0.2. Okay, can so this is how you're going to do in exam, guys. Exam are just empty spot. You'll just do whatever you can do. Okay. Once I have the number of mole of magnesium oxide, step 2 is to compare what I have is MgO. What I want is the MgNO32. Correct or not? Okay. But the good news is there any number in front of MgO and the MgNO32? Don't have, right? So the ratio is 1 to 1. Okay, then you're gonna get 0.2 to 0.2. So what is this? This is number of mole of the magnesium nitrate. Okay, and step 3 is finally you're going to close up your calculation. You are looking for the mass of magnesium nitrate. So I'm going to use the same formula, but then, of course, for different number of mole, number of mole of magnesium nitrate equals to the mass over molar mass. Okay, I'm going to put it here. So it will be 0.2 equals to mass of magnesium nitrate. But what is the molar mass of magnesium nitrate? This one, guys. There's no final answer given to you, the molar mass of magnesium nitrate. You're going to total up magnesium nitrate yourself. Okay, so what you're going to do? Do the calculation. Magnesium is 24, NO3 bracket 2. N is 14, O3, 16 times 3. Okay, and then this whole thing times 2. Okay, because it's Mg and O3 NO3 whole thing times 2. Okay, so you all do the maths. Okay, so 16 times 3 plus 14 times 2 plus 24. Okay, so you get 148 and multiply 0.2. Okay, so this one, guys, this total is 148. I guess so lah. Okay, I press my computer calculator. Okay, so you multiply over. Okay, you're gonna get your mass of magnesium nitrate is 148 multiply 0.2. You're gonna get 29.6 gram. Okay, this is what I get lah. Let me check my answer. Answer correct. Okay, so guys, exam like this, empty spot, write your own 3 steps. Whoa, guys, I got student 10A plus. Nice. feel so proud. So happy for them. Okay, so guys, so the last 8 minutes, okay, I try to do one more question lah. Okay, so if you go down, okay, next page lah, page number 35. Okay, we have something like this. Okay, question 9B, okay, show the airbag. Okay, it's one of the safety feature in your car. Okay, now airbag contains solid sodium azide, which is the NaN3, that decomposes rapidly into sodium metal and nitrogen gas when car accident occurs. Nitrogen gas produced will fill up and expand the airbag. Okay, you can see, write the balanced chemical equation for the decomposition of sodium azide. So guys, you see, so this question now, the hard part is you're gonna write out your own equation even without learning all this concept, correct? So, but then they always give you all the hint on it. See, they say solid azide NaN3 decomposes into sodium metal and nitrogen gas. So guys, what is decompose? means break up and then form into smaller parts. So what we can write in an equation is you started off with Na, N3, and then decomposes like break up, and then break up become what? Two things of sodium and nitrogen gas. So you see, break up into sodium, what sodium? Na. What is nitrogen gas? N2. Okay now. So guys, balance your equation. That's all. Okay now. So even though you say, teacher, I never learned this thing before, guys, you don't even need to learn this thing before. They told you that in the question. Just convert the sentence from word, okay, towards your symbol. So Na, N3, okay, from Na plus N2. Okay, so they are all according to where? To the question. Okay now. So you balance equation, you're gonna get 3, 2, 2 like this. Okay, so 6N and then 2Na, 2Na lah. Okay, so now if the volume of your airbag is 57.6 dm cube, right? So we say that volume of your airbag, volume airbag, calculate the mass of your solid azide that has to be in each airbag. So it means, guys, because we know what is the thing that fills up the airbag? You see, is the nitrogen gas will fill up and expand the airbag, So who is the one? Even though they never say the volume of what is 57.6, right? But from here, we're supposed to know the volume of this thing. It's supposed to belongs to your nitrogen gas because it's the nitrogen gas that fill up the airbag, so this is like a concept like, this airbag is this big, Okay, this airbag is so big. Okay, 57.6 dm cube. How much chemical I need to use so that later on, if really like happen accident, I need sufficient nitrogen gas only can fill up the airbag. Kind of. If you go and like use lesser chemical, then your airbag not enough. Your airbag like not safety enough, kind of. So you can see that. So volume of airbag is 57.6. So we can say that calculate the mass of the sodium azide need to be in each airbag. Means I need to find the mass of the chemical so that later on can produce how much your nitrogen gas. So with that nitrogen gas, we can say from here, we want to produce 57.6 dm cube. Okay, only can fill up your airbag right now. How much is the mass of the sodium azide in the front? So we can do the same calculation. Started off with the volume, but volume, guys, what's the formula? Volume over molar volume. So see, volume over molar volume, 57.6 divided by 24. Given by question, the molar volume. So you get 2.4. Okay, but then again, what you have is nitrogen gas. Okay, the number of mole of N2 is 3. And then what you want is the mass of sodium azide, right? So what you can do is, your concept will be something is, what you have is N2. What you want is NaN3. Correct, you see? What I have is N2 is 3. What I want is the NaN3 which is only a 2 in the front. So it's 3 to 2. So if it's 2.4, what is your ratio of your NaN3? So you divide 3 times 2. Okay, so divide 3 times 2 will be, I think, around 1.6, if not mistaken. So I think it was something like this, you see. 3 mole N2 produced by 2 mole of NaN3. So therefore, 2.4 mole of N2 produced by 1.6 mole of NaN3. Okay, now. So with this 1.6 mole, how can I find mass? Mass over molar mass. So you see, the next one will be mass over molar mass. That's like NaN3. Molar mass total up yourself. Bring over multiply. You get this 104 mass. So you need to put like 104 gram of this sodium azide into the airbag. Later on, if accident, only your airbag can become maximum size. Okay. If you go more than this, your airbag might explode. If you go less than this, your airbag might be too soft. So not safe enough. Okay. And the last part, okay, so this one is something also will get wrong also. The reaction between liquid ethanol with oxygen gas produces carbon dioxide and water. Guys, again, they give you word. Can you write the equation? So we have liquid ethanol, which is C2H6O, with oxygen gas plus O2 produces carbon dioxide gas and water, CO2 and H2O. Don't forget the balance equation. So from here, 2C on the right, also 2C lah. And then on the left, we've got 6H. On the right, I also put a 6H lah. Okay, so try times 3 lah. So in overall, how many O we have? 2 times 2 is 4. 3 times 1 is 3. So 4 plus 3 in total is 7 oxygen. So if it's 7 oxygen, here already got 1. So how many oxygen I need for here? 6. So I times 3. So like this, you see, so 1 plus 6 is 7, and then 4 plus 3 is also 7. Okay. Again, so overall, all this, okay, is the balance equation. Okay, and then lastly, what is the volume of the unreacted oxygen gas? Guys, this one very important. You see, they give you 2.6 gram of ethanol with 6 mole of oxygen gas in excess completely. Okay, so guys, do you realize this question gives you two unknowns? Sorry, two values. Usually, stoichiometric only give you one value, and then you just start with the value, and then you do ratio, and then you do mass, you find mass, find volume. But if the question gave you actually two different values, okay, and they told you that the oxygen is in excess, what you do is you always don't use the excess. Why? What's the meaning of excess? Excess means that you supply it too much. Means that you don't use everything. Means that the 6 gram, the 6 dm3, right? Did you use all 6 dm3? No. Why leh? Because you see, it's something like this. The concept like this, so you have 2.76 gram of ethanol with 6 dm3 of your oxygen gas, right? One of it will actually finish first. And which one finish first? The one that is not in excess, which is the ethanol. If ethanol finish already, the leftover oxygen, will it have reaction to form CO2, H2O? No. So the concept in exam, every time you have two different values, right? You actually calculate the number of mole for both of them, and then you always choose the lesser number one. Always choose the lesser number of mole, because that is your limiting agent. So the one in excess is now in oxygen, your oxygen. So what do we call the one that is in lesser? We call this the limiting reagent. Okay. So always use your limiting reagent as your calculation. Okay, because the one in excess, you never finish. If you never finish, how you know in the 6 dm3, how much you use? Maybe he used 4, left over got 2. Maybe he used 3, left over got 3. Or maybe he used all the 6, you don't know. Correct. So the point is, if you see question like this in exam, you have two different values given by question. Always use the limiting reagent. Use the one that is not in excess. Okay, but if they never write like this, because this one, the lucky part is this one, they tell you in excess, oxygen in excess. So you can straight away deal with the ethanol. No need to think about oxygen. Just use ethanol in your calculation. Then you can actually proceed with your calculation. Then later on, when you can calculate your volume of oxygen gas, you take the 6 minus the one that you use out. Okay, so what's the meaning of this? You see, from here, what I can do is I can start with my first calculation. I use you see, from here, I do my number of mole equals to mass over molar mass for my ethanol. You see, do as usual, guys. No difference, correct? Do as usual. But then what you're looking for is the volume of unreacted oxygen. But you cannot find unreacted oxygen directly. What you can do is you can find the reacted oxygen. So how to find reacted oxygen? Ratio, you see, 1 to 3, you see 1 ethanol to 3 oxygen, right? So 1 to 3, and then 0.06 get you 0.18 of oxygen. Okay, and then you use this 0.18, you do a calculation to find volume of oxygen. You see volume over molar volume, you take the 24 over multiply the 0.18, you use you found that it's 4.32 dm3. So guys, what is this? What is this final answer? It's 4.32, but is that your final answer? No, because this 4.32 is what you use. What is the volume of the reacted oxygen gas? So it means that if you want to burn your ethanol, okay, if you want to like get a complete reaction for ethanol, you need to use up 4.32 dm3 of your oxygen gas. Correct? But then, is that the final answer? No, because what they give you is 6 dm3, but you only use up 4.32. So what is the unreacted oxygen gas? You take the volume of gas that they give you minus of the gas that you reacted, that you use up, then the leftover is the gas that never used up. So the 1.68 is actually the volume of oxygen that you never have reaction. Okay. Why never have reaction? Because very simple. The reason, okay, the calculation, all this, right, is basically we assume that we use up all the ethanol. Correct? So if you use up all ethanol, you only use up 4.32. You get it? Means the remaining 1.68, right? There's no more ethanol for him to react. So that's why this is called the volume of unreacted oxygen gas, because these are the leftover of oxygen that no more ethanol to react. So if no more ethanol to react, then we say this is actually the unreacted oxygen gas. Yeah, so this is one of the possible question in exam also lah. So be careful on this, where they didn't ask you to find volume of oxygen gas. They ask you to find volume of unreacted oxygen. So what you're gonna do? You find the volume of the reacted oxygen first, then you take the total minus the reacted one, then you get the unreacted one. Okay. So what we can say this one, guys. So the 4.32 is the volume of oxygen gas reacted. Okay. And so you take the 6 minus the 4.32, you get the volume of unreacted oxygen gas. Okay, guys, is that clear on this? Can all good? So guys, hopefully this 2-hour seminar brush up every topic. Okay, so I go through what? I go through isotope, I go through heating curve, cooling curve, I went through empirical formula, I went through calculation. Okay, all these small topics I do already lah. So hopefully in your coming exam, right, at least this part, these 2 chapters, you all can score very well. But I think your coming exam also include chapter 4 okay. So chapter 4, that one we are still doing in our normal class. So we still learning through that. Okay, so that one you all still fresh ma. So chapter 2 and chapter 3 is the one that you all forget already. So hopefully this one refresh your mind a bit. Okay. So guys, if okay, I will call it a day for today lah. Thanks for coming during holiday. Okay. I'll see you when I see you. Thank you guys. Bye-bye. Bye guys. Bye-bye. 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 Mm-hmm, mm-hmm.